Alright, now in this video, I want to talk about examples on the union and intersection of sets. Alright, but first, I want to remind you of the definition I gave to you guys based on the union of sets and the intersection of sets. Okay, and here I'm going to be using the set builder method. It is very important to know this one also. In the example I gave when I introduced the union and intersection of sets, I was making use of the listing method. Right, so I will begin to be making use of this set builder method, this way of representing the sets of elements. Okay, so if A and B are two non-empty sets, that is to say A and B contain at least one element, right? Okay, then A union B will be equal to element X. All right, now when we use this, we say element, the A union B is equal to, it contains some element X such that X belongs to A, or X belongs to B, or X belongs to both A and B. Now the idea is that union of sets, okay, the union of two sets A and B means elements that contains in A and elements that are contained in B. So the union of two sets will return to you the elements from the set A together with the element from the set B. Alright, so it will just take all the elements and store it in a new element called A union B. Alright, that is what we are saying here, that if X is an element of A union B, it means that X must be an element of A, or any X must be an element of B. Okay, alright, so this X shows all the elements of the set A and B such that X belongs to the set A, or X belongs to B, or X is a common element between A and B. We can collect such and store it in A union B. Okay, the same thing goes, but on the other way, for the intersection of sets. If we have A union B, A intersection B, this is given by X, right? Yeah, such that X belongs to A and X belongs to B. So from the definition of intersection, we talk about elements common to both A and B. Okay, so if X must be in the set of intersection of A and B, it means that X must exist in both A and B. Alright, so that's why I'm saying X is an element of A, and this "and" is different from "or". Alright, "or" means it can be in A, it may not be in B. Okay, X can be in A or X can be in B, but "and" means it must exist in both sets, right, for it to exist in the intersection of both sets. Okay, so that's just the background a little bit. Let's go into the examples right away. We see here that A is equal to element X such that X is less than or equal to 2, alright, and X belongs to the set of natural numbers. Now when we talk about the set of natural numbers, we mean the set of counting numbers. Okay, that is starting from 1, 2, 3, 4, 5 till positive infinity, just whole numbers. Okay, as long as you can count it. So that is where X is from. X is an element of this set. Okay, so if X should be an element of that set and X is said to be less than or equal to 2, we want to list out the elements of the set A. It means that A will contain this kind of X. X will be an integer, but it should be less than or equal to 2. Okay, sorry, a natural number, but it should be less than or equal to 2. So natural numbers less than or equal to 2 will be 1. That is the first natural number. Okay, the next thing is 2. Now the next thing should be 3, but since X is said to be less than or equal to 2, that means we're going to stop there. Alright, if it was X less than 2 only, strictly less than, then it will just be only one element, only the element 1 that will be there. So that is it for the set A. So let's talk about the set B by listing it. So we see here that set B stores element Y. Now this is the property of the Y. Now Y is such that Y is greater than 1 and Y is an integer. Now an integer and the natural numbers are equal when we talk about numbers greater than 0. So integers are just whole numbers. Okay, both negative whole numbers and positive whole numbers. Those are the integers. Alright, but the natural numbers only take care of integers, whole numbers greater than or equal to 1. Okay, so that means that the natural number is a subset of the set of integers. Okay, but that's by the way. Now B here is said to be element y such that y is greater than or equal to 1 and y belongs to the set of integers. So we start with 1 because it is either greater than 1 or equal to. So we start with equality. We store 2, we store 3, we store 4, we store 5. Now this is a set of integers, okay? It's just whole numbers from negative infinity to positive infinity. It has no end, all right? Okay, so that is why I'm putting these 3 dots. It continues like that. Now we want to talk about A intersection B. Okay, let me put it over here. And then A union B. So A intersection B will now be, now by definition of intersection, we talk about elements common to both A and B. So A has element 1 and B has the element 1 also. So that is going to be 1 because it exists in A and it's also in B. A has 2 and B also has 2. Okay, so that means the 2 will be in the intersection of those two elements. Now A does not have any other elements, but B has others. But since A does not contain 3, A does not contain 4, so 3 and 4 and 5 and so on will not be in the intersection. So that is the end of it thereof. Alright? Okay, so the next thing we'll talk about is A union B. Well, let me put it down here. A union B will mean the element that are found in both A, the set A and the set B. So 1 is found in the set A, 2 is found in the set A. Now 1 is in set B. Okay, we are done with the set A, so we move over. Since we just want to collect all the elements that are in set A and B. So since 1 is in set B, we've already written down the 1 from the set A. There is no point to repeat element in sets, alright? 2, the same thing. So we go with 3, we go with 4. You see the next one will be 5, 6, and so on till positive infinity, which we can't list, okay? There are many, alright, though they are countable, but very, very many. Infinitely many. So that is it. So this will be the element of A union B, while this is just element of A intersection B. Okay, so that must have been a very nice example. Okay, and this will be a nice place to end the video. So with this, you can go ahead and solve many problems under union and intersection of sets. I'm going to post a second example which will be a little bit tough. Okay, so stay alert and thanks for watching. Please subscribe to this channel.